Video Demo, Volume Increase Upon Neutralization by McMullin. In this experiment, we will be adding 50 milliliters of 2 molar hydrochloric acid to 50 milliliters of 2 molar sodium hydroxide. After neutralization occurs, the volume of the solution is more than 100 milliliters by about 2 to 3 milliliters. We will be exploring where this extra volume of solution came from. For this experiment, you will need an 100 milliliter volumetric flask and two 50 milliliter volumetric flasks. You will also be needing various funnels for pouring the solutions into the flasks. For reactants, we will be using 2 molar hydrochloric acid and 2 molar of sodium hydroxide. We will also be using a universal indicator and distilled water for our control experiment. For our controlled experiment, we will be measuring two 50 milliliters of distilled water. We then added both volumes to a 100 milliliter volumetric flask. The result was exactly 100 milliliters of water. Demo time. First, we added 50 milliliters of hydrochloric acid into a 50 milliliter volumetric flask. We additionally added a few drops of universal indicator to make it easier in seeing the neutralization reaction between the strong acid and strong base. Don't forget to remove some of the excess volume added by the indicator. After measuring out 50 milliliters of sodium hydroxide, it was time to mix the two solutions together. First, we added the hydrochloric acid volume. Then we added the sodium hydroxide, 50 milliliters. When the two solutions mix, there is a slight dark blue color change on the surface. This is caused by the sodium hydroxide reacting with the universal indicator. As the volume of added base increases, the solution begins to fill the neck of the flask where the diameter is smaller. This portion of the solution has a light blue color because the sodium hydroxide is only reacting with the indicator and has not yet neutralized with the acid. As the reaction continues, the acid and base mix thoroughly and the solution color is red. Typically, the solution would be green because the acid and base are of the same concentration, but this result suggests that the acid was in fact more concentrated. Notice that the final volume of the hydrochloric acid and sodium hydroxide reaction is greater than 100 milliliters. Why? One of the reasons for this increase in volume is the partial molar volume. Partial molar volume of a solute is defined as the molar mass over the mass density. These partial molar volumes can determine the change in volume during a reaction. This is the equation. For this reaction, it would be partial molar volume of sodium chloride plus water minus the partial molar volume of hydrochloric acid and sodium hydroxide. In this case, the numbers are 1.66 plus 1.8 minus 1.8 minus negative 0.52, which equals a change in volume of 2.19. The reason why there is not an exact volume change of 0 is because there are more particles produced in the reaction. Since the molarity of the reactants are relatively high, 2 molar, there are more water molecules being produced. Another reason why there is more volume is because of electrostriction. Electrostriction is the drawing of matter in a non-uniform electric field. The electrostriction of an ion is much greater because they attract the matter around it. To understand why there is an increase in volume, we must look at the difference in electrostriction between the reactants and the products. Let's look at the ions in our reaction equation. You can see that the reactants have 4 ions: hydrogen cation, chloride, sodium cation, and hydroxide, and the products only have 2 ions, sodium cation and chloride, with water having a partial charge. Since the products have fewer ions in the same volume, there is less drawing of matter, less electrostriction. For instance, the hydrogen cation is surrounded by the delta negative oxygen from the water molecules. However, since one of the products is water, and water has a partial charge, it is not as compact. When a reaction goes from a higher electrorestriction to a lower electrorestriction, there is an increase in volume. Now you know why there is an increase in volume upon neutralization. Thank you for watching.